Hey everyone, welcome to homework 5.6. Today your homework is shorter in the sense that you have less questions, but these are all PARCC released items, which means they are practice PARCC problems. So it is very important that you do these, okay? All right, so question number 1 has the drawing of an opening in a garden wall, right? So there's some kind of like door or opening in this garden wall, and it's shaped as a parabola, right? So it's got that U shape, and the height of the opening h is a function of the distance d from the left end of the wall. So this means this is the left end of the wall, right? So the distance here is what is being measured as our input for this function. All right, and so this, if you think of this, if it's helpful for you, think of this as your coordinate plane, right? So this is your y, this is your x, or in this case, this is your height, h, and this is your d, distance from the wall, okay? So if it's helpful, think of that as a coordinate plane. That's what I thought of when I saw this. So first it asks us, what is the factored form of this function? Now this one's a little bit different because you have a -2 in front of it, and notice that all of these can be divided by 2. And you see here that it's created 3 spaces for you to factor. So what I'm going to start by doing is factoring out -2. So -2, and then I'm going to write what's left in parentheses. So -2, -2d squared divided by -2 leaves me with d squared. 12d divided by -2 is going to be -6d, because -2 times -6d will give me positive 12d. And -10 divided by -2 is going to give me positive 5. So -2 times positive 5 gives me -10. I can check. So now that means my first factor out of this is going to be -2. Now I can factor this middle part as I normally would. So I'm looking for factors of 5. 5 is a prime number, so it has to be 5 and 1. And it's going to be d minus and d minus. d minus 1 times d minus 5, because -1 times -5 gives me positive 5, and -1d and -5d will give me -6d. So notice it gave you d minus 1 here already, so you know that that's good. So that means the other answer is going to be 5 there. That's what we would enter in those boxes. It says select the phrases to complete the sentences. So this is this equation in factored form, which means that d minus 1 equals 0 is one solution, and d minus 5 equals 0 is the other solution. So that means I can add 1 to both sides, and we get d equals 1. I can add 5 to both sides, and that means d equals 5. So that means that my distance here is either 1 or 5 away from the wall, from the end of the wall. So it says, select the phrases to complete the sentence. The largest value of d for which h equals 0, which means, what is the largest value for d when h equals 0? Well, we solved for when h equals 0 up here, and the largest value, our values were 1 or 5. So our largest value is going to be 5. It says the value is the height of point B, the distance from point A to C, the distance from the left end of the wall to point A, or the distance from the left end of the wall to point C. Well, 5 would be here, and so that is representing the distance from here to here, because that would be our x-intercept. That's not to scale. Notice it says not to scale, so don't try to count points here or anything, right? This would be 1, this would be 5, so it's that distance from the left end of the wall to point A. Oh, sorry, to point, make sure I did that right, to point C, right? So we're looking at here, that distance from the y-axis. So the distance from the left end of the wall to point C. All right, now, if it's helpful for you, think of this as this is the parabola, right? And so this is the end of the tunnel on that side, and this is the other end. So this is A, this is C, right? This would be 1, 2, 3, 4, 5. I didn't draw that super well, okay? But this would be 1 point away, and this would be 5. All right, question number 2. A parabola with this equation, a times x minus b squared plus c, has a minimum at the point 2, -1 and a y-intercept of 3 when graphed in the xy coordinate plane. What are the values of a, b, and c? All right, so b and c is quite easy because that is our vertex. So I'm going to fill in y equals a times, remember b and c right here are our vertex, so x minus 2 squared plus a minus 1. So plus -1 is the same as -1. All right, that's our vertex. Okay, it says a y-intercept of 3. So we don't know what a is, but if we know the y-intercept is 3, we know that is 0, 3 is a point on our graph. So now I have an x and a y value, so I can plug that into the equation to solve for a. So I'm going to plug in 3 equals a times 0 minus 2 squared plus a -1 or -1. So now I can rewrite this as 3 equals, well, a times -2 squared is just going to be 4 minus 1. And now I'm going to solve for a. So I'm going to do so by adding 1 to both sides. And then I will get 4 equals a times 4 or 4a. I can divide both sides by 4 and I get a equals 1. All right, that makes sense because that would mean that our parabola just has a very normal size to it, no vertical or horizontal stretch. So a equals 1, b equals 2, and c equals -1. Okay, now notice I'm saying that b equals 2 because this negative is part of the equation. So I'm plugging in a positive 2 for b. So our values are 1, 2, and -1. All right, let me just reiterate that. We know that this is the vertex. So using vertex form, I can plug in my vertex, my x and y's. All right, I'm just plugging in for b and plugging in for c. Okay, then I need to find out what a is. That tells us how narrow or wide our graph is. It's our vertical stretch or vertical compression. And I am going to use this point 0, 3 to find out what a equals. All right, let's take a look. Oh, sorry, at part B. What are the x-intercepts of the parabola? Select all that apply. Okay, so we're going to have to do a little bit more work for this. Now, I do want to note that I believe this question was a question for which you could not use the calculator. So this does require you actually like using your brain and calculating and not necessarily checking it in the calculator. So I just erased the equation, but it was y equals a is 1, so x minus 2 squared minus 1. So what I can do is I can put this into standard form. So this is going to give me y equals x minus 2 times x minus 2 minus 1. That's what x minus 2 squared means. So y equals x squared minus 2x plus 4 minus 1, or y equals x squared minus 4x plus 3. Okay, now I can factor to find my x-intercepts. So I'm looking for factors of 3 that add up to equal -4. So it's going to be x minus 3 and x minus 1, because this will give me x squared. -3 times x is -3x. -1 times x is -1x. That gives me my -4x. And a -3 times a -1 gives me a +3. So I can now solve this to find my zeros. So x minus 3 equals 0 means that x equals 3. And x minus 1 equals 0 means that x equals 1. So my zeros are E and G. All right. If you get an equation in any form, you can always turn it back into another form and then manipulate it, right? So in this case, we had it in vertex form. This right here is vertex form, right? I turned it into standard form, and then from standard form, turned it into factored form. All right, let's look at question number 3. The function h of t equals negative 16t squared plus 48t plus 160. You should recognize this is gravity for feet. All right? It is dropped from a building that is 160 feet tall. We can see that. They didn't need to tell us that. Two other forms of the function are this form and this form. Which value of the function represents the maximum height of the object? So the maximum height of the object would be at the vertex. This is a negative coefficient, which means it's going down, right? It's open down, it's a frown, it has a negative, right? So this is the maximum height. The maximum height is the vertex. So looking at this, this gives me factored form, which would give me my x-intercepts. That's great, but that's not what I need, right? I want to find this point right here. So to find this point right here, I want it in vertex form. This form right here is where we have vertex form. And for this form, in vertex form, our vertex would be 1.5, comma, 196. So that would be, this would be 1.5 here. This would be 1.5, comma, 196. That's our vertex. So the value of the function that represents the maximum of the height would be b, h of 1.5. Okay? H of 2 would be actually nothing. H of 5 would be one of our x-intercepts. All right, but we don't need one of our x-intercepts for this because that would tell us when it's on the ground, not when it's at its highest point. H of 0 would give us the starting value, which is 160, but that's less than 196. All right. Question number 4. A quadratic function is graphed in the xy coordinate plane. So this function right here we can see has a vertex of -1, comma 1. That's its vertex, right? In which quadrant, would the vertex where x plus 3 and then plus 2 be located? So if we were to change the x values to be plus 3, where would that go? And then if we were to change the y value by adding 2, where would that go? So that means, remember, when it's a plus 3, we're going to move in the opposite direction that we think. So we're going to go over 1, 2, 3, and then we would go up 2. So this is up 1, 2. So our new vertex would be here, right? Shoop, shoop. And so with this new vertex, our graph is very solidly, the vertex is very solidly in quadrant 2. All right, question 5. What is the equivalent form of this function that reveals the zeros of the function? So you don't even need to do a lot of math for this. These first two forms are vertex form. So they don't show you the zeros, they show you the vertex. We can eliminate A and B. This is vertex form. This gives us a vertex of -4, 4, comma 4, and 4, comma 4. We don't need that. We're asking for the zeros. So it either has to be C or D. Well, the question now is which one will give us these negatives? So what we're going to do is FOIL them. So this would be, put that negative out there, x times x is x squared, 2x times x, 2 times x is 2x, and x times 6 is 6x, so that's plus 8x. And then 2 times 6 is positive 12. But then we would distribute this negative, and that would make everything negative x squared minus 8x minus 12. So this one looks good. That looks the same as that, right? So I'm going to say C is pretty good, but just in case, let's check this one out and see why it isn't. So this one, we would have the negative x times x is x squared, minus 2x minus 6x would be minus 8x, and then negative 2 times negative 6 gives me positive 12. So here, when I distribute my negative, I would get negative x squared plus 8x minus 12. And so this is almost correct, but that middle term gets messed up here because of these negatives here. Because a negative times a negative gives us a positive. So C is our best answer. Remember, even if you think you get a good answer, check the other ones below it just in case. All right. Number 6, select the values and signs for the drop-down menus that complete the solution by factoring. So here we want to factor this problem, okay? This would be a non-calculator problem because they want to see that you can factor. So multiples of 3 that give me, factors of 3 that give me -4. Well, 3 is a prime number, so it has to be 3 and 1. And we want them to add up to be -4, so they're both going to be negative. So this would be x minus 3 and x minus 1. It doesn't really matter what order you put them in. So if you chose x minus 1 and x minus 3, that would also be fine, right? Because you can rewrite this as x minus 1 times x minus 3. Totally fine to switch those factors around. That means, though, that x minus 1 equals 0 and x minus 3 equals 0. If I add 1 to both sides here, x equals 1. Add 3 to both sides here, x equals 3. So our answers are x equals 1 and x equals 3. All right, that is it for your homework. Those are some PARCC review problems. If you have any questions about these, or you weren't sure how to do something, or you wondered why something, please ask. Ask, because these are perfect examples of the types of problems you will see on what is now called CAPE. So your code word for today is CAPE. See you tomorrow.